Hey, what's up, guys? It's Synchrolad here, back again with a video and a reaction at that. And right now, I'm looking at a video called How a Mass Extinction Event Created the Amazon. It is on the PBS channel. It just came out on my recommended, and I thought it would be a nice video to react to, something educational. I don't know if there will be any issues with the copyrights, but I'll just give it a go. See what I or we could learn about this. Let's have it a go, shall we?
The Amazon rainforest of South America is a paradise for plants. It's so lush and verdant that it's not only home to about 10,000 animal species, it also hosts at least 14,000 species of plants, maybe as many as 50,000. And it's so big that it essentially regulates the climate of the entire continent. And the Amazon's amazing powers are mostly possible because the vast majority of its plants are flowering plants. From towering kapok trees to small flamboyant orchids. Flowering plants are known as angiosperms, and they're primarily responsible for making the Amazon the most diverse ecosystem on the planet. Large trees create a crowded overstory with a thick, closed canopy of leaves that block out most of the sunlight. In the rich understory below, a variety of small trees and shrubs have evolved to thrive in the gloom. But it wasn't always this way. Long ago, the landscape that we now think of as the Amazon looked very different indeed. Maybe half of the plant life there wasn't flowering plants at all, but instead was made up mostly of ferns, along with some gymnosperms, the group that includes conifers, cypresses, and cycads. For hundreds of millennia, these two groups, the flowering plants and the non-flowering ferns and gymnosperms, maintained a precarious balance, a standoff over control of the entire region. So what allowed flowering plants to take over, to create the Amazon that we know today? And how quickly did this change happen? Well, would you believe that the entire revolution of the Amazon began with just one day? And it would be a very fateful day for a group of animals who, we think, can take some credit for the takeover of flowering plants. The dinosaurs.
Alright.
In terms of evolutionary time, flowering plants are newcomers. For as long as there's been life on land, which is about 470 million years and counting, plant life has mostly consisted of ferns, gymnosperms, and even older plants called lycophytes. Flowering plants don't show up in the fossil record until about 135 million years ago. For the first several million years of their history, they were just tiny shrubs, and many of them were probably aquatic. But by the time that epic battle of the Amazon reached its peak more than 70 million years ago, flowering plants had diversified and spread. And in the Cretaceous forests of what's now Colombia, they made up almost half of the known plant species, but still weren't able to outcompete the non-flowering plants. They were in a stalemate. But that stalemate would be suddenly broken one day about 66 million years ago. That's when, and stop me if you've heard this before, an asteroid impact occurred off the coast of Mexico that would trigger what we now call the Cretaceous Paleogene Extinction event. The force of that collision may have vaporized trillions of tons of rock and launched fragments into the atmosphere, where they rained down across the globe. Their re-entry created so much heat that ground temperatures may have risen as much as several hundred degrees in less than an hour, starting wildfires all over the world. Plants that managed to escape the flames were starved of sunlight, as a thick plume of dust, soot, and aerosols blocked out the sun for probably over a year. And this was just really bad news for many animals, especially huge dinosaurs that needed large quantities of food to stay alive. But the devastation didn't wipe the slate clean for plants. Thanks to resilient spores and seeds that could wait around for years for conditions to improve, no major groups of plants went extinct because of this impact. But it did reset ecosystems and the way plants interacted within them, including in South America. And we know this because researchers spent 2 decades studying a massive number of fossils from 39 different locations in what's now Colombia. They painstakingly identified thousands of leaves, spores, and pollen grains from places that included fossils of plants both before and after the asteroid impact. And they found that at pre-impact sites, ferns and gymnosperms made up 52% of the plant diversity, while flowering plants made up 48%. So until that big space rock came, they were pretty close to even. But in post-impact sites, fossils showed that angiosperm diversity shot up from 48% to 84%.
Wow.
So, okay, the asteroid impact changed the structure of the forests. But how? And why did that tip the balance between the ferns and gymnosperms and the flowering plants that had lasted for millions of years? Well, one explanation is that when the ash from the impact finally settled, it released tons of phosphorus over the land, equivalent of a giant fertilizer bomb. While adding a bunch of fertilizer might seem like a good thing, it may have ultimately sped up the extinction of many gymnosperms. Because most gymnosperms thrive in low nutrient environments by being water efficient and growing slowly. So all that extra phosphorus gave the faster growing angiosperms a competitive edge. And gymnosperms suffered another blow from an unlikely source. Legumes, or bean plants, which began to diversify almost immediately after the extinction event. Legumes are angiosperms, and they have symbiotic bacteria in their roots that can pull nitrogen from the atmosphere, which plants can't do by themselves. And since nitrogen is a limited nutrient in just about every terrestrial ecosystem, being able to make their own fertilizer allowed legumes to diversify really fast, while gymnosperms kept declining. But even a giant fertilizer bomb probably wouldn't have been enough to tip the scales. There was another factor to consider: the dinosaurs. When the world's forests regrew after the impact, the dinosaurs that used to live there were conspicuously absent, and their extinction had rippling effects on the ecosystems that came after, especially in the Amazon. Before the impact, big herbivorous dinosaurs kept the understory open by trampling plants, and opened up gaps in the canopy by munching on leaves. Gymnosperms and ferns thrived in these bright, disturbed habitats. But after the impact, there were no more big dinosaurs keeping conditions just right for those plants. And researchers tested this idea by studying not only the types of plants that grew before and after the impact, but the types of environments they created. Specifically, they wanted to know whether the forests were open canopy, where the crowns of the trees don't touch each other, letting light reach the forest floor, or closed canopy, where the crowns of the trees form a continuous layer of shade. First, the team looked at the density of vascular tissue in their fossil leaves. Plants growing in open sunlight tend to have a thick mesh of veins that carry water and nutrients through the leaves. But leaves that grow in the shade have vascular tissue that's more evenly spread out. Second, they looked at ratios of carbon isotopes in the fossils. Depending on what type of forest a plant grows in, open and airy or closed and humid, and where in the forest the plant grows, its leaves will have different carbon isotope ratios. In a closed canopy forest, there's a much bigger difference in carbon ratios between the upper canopy and the dark understory, because the difference is in the amount of CO2, water, and light that the leaves are exposed to. But in an open canopy forest, the isotope ratios in the canopy and the understory are more similar. So by these two clues, researchers could tell that the pre-impact sites were mostly open canopy forests, full of bright open spaces for ferns and gymnosperms to grow in. But after the dinosaurs disappeared, RIP, post-impact sites quickly changed to the closed canopy Amazon forests we have today. And it's in these closed canopy forests where flowering plants outgrew their gymnosperm competitors and made conditions too shady for them, if you know what I mean. So, the asteroid impact dropped a fertilizer bomb on the planet and wiped out the non-avian dinosaurs, which changed the environmental conditions that many gymnosperms relied on, all leading to the birth of the Amazon rainforest we know today, one filled with flowering plants. Ferns and gymnosperms are still around, of course, and some ferns were even able to capitalize on the rise of blooming tropical forests by adapting to thrive in low-light conditions. But the balance has mainly shifted in favor of the flowering plants, thanks in part to the dinosaurs, but mostly to the asteroid impact that wiped them out. It's strange when you think about it, maybe a little ironic, maybe a little bittersweet. It took a mass extinction to give rise to one of the modern world's biodiversity hotspots, and to pave the way for the reign of the flowering plants of the Amazon. So now that you know how flowering plants took over, you might be thinking, how did flowering plants evolve? Well, check out when did the first flower bloom? And thanks to this month's eontologists for believing in us. Sean Dennis, Jake Hart, Annie Eric Higgins, Luis Vieira Pinto Neto, and John Davison Ng. By becoming an Eonite at patreon.com/eons, you can get fun perks like submitting a joke for us to read. Like this one from Cassie. Okay, here we go. Brace yourselves. Why are the best people to date paleontologists? Oh, this would be good to know. Because the older you get, the more they dig you. I see no lie. And as always, thanks for joining me in the Constantine Haase studio. Subscribe at youtube.com/eons for more journeys in deep time.
Okay. I apologize if I did not commentate throughout the video. I just try to get all that information in without talking over. But basically what I took about out of that is like, you know, that whole thing about before creation comes destruction kind of situation. And it is neat to know about how the meteor that eventually wiped out the tyrant lizards, the big lizards, the dinos, had caused this effect over the plants, and the absence of the dinosaurs that maintained sort of like a balance with the ferns and the plants eventually just died away and paved the way for the other kind of plants to, just become more fruitful, and yeah, it was pretty cool. I don't know if I'll react to more of PBS eons. Maybe if I see one in my recommended lists. But yeah, that was the video. That was a How a Mass Extinction event created the Amazon. Yeah, getting late now. I should probably head to bed. But all in all, I hope you enjoyed. Yeah, I'll see you guys in the next one. Adios.